All right, we're almost there. One more lecture in the main class, which means we'll be giving a review of that topic on Thursday. But we're almost done with new content. So today we're reviewing ellipses, basic equations of ellipse. Have x squared over a squared and y squared over b squared. Add them together, you get 1. That's for an ellipse centered at the origin. If it's not centered at the origin, but centered at HK, we do the shift that we've been doing this whole time for different kinds of things. C squared equals the absolute value of a squared minus b squared, gives us information about our foci. Our foci are along the major axis. And the major axis is the variable associated with the max or the largest of A and B. So if A is larger, it's with X. If B is larger, it's with Y. And where are the foci? The foci are actually plus or minus C from the center. Along the major axis. As a reminder, E is for eccentricity. And for ellipses, well, you'll see this covers both ellipses and hyperbolas. It is going to be C over, I found a better way of saying it, max of A and B. Whichever one of those is larger, that gives us our C. Or that we're going to use that one on bottom, which basically means the value associated with the major axis. Or distance from center along the major axis. This is going to work for hyperbolas, which we're doing today. The only difference is C, we're going to find C in a slightly different manner. For eccentricity, circles have an E equal to 0. When we have E is larger than 0 but less than 1, this is where we get our ellipses. When E equals 1, that's where we have our parabola. And as we'll see later today in the next section, E greater than 1 is going to generate hyperbolas. And eccentricity is a measure of roundness. So let's look at doing some examples. Yeah. Let's start there. Nothing beats an example straight from the homework, right? Look at this collection of notes. All right. First example is, or first question from our homework is, graph the given equation. And give domain and range. And the given equation is y over 9 equals square root of 1 minus x squared over 49. Oh, you got 2. There's 2 per, all right, we'll do both. All right, so this is similar with what we did in 10.1 with the parabolas. We got a square root. The square roots are a pain in the ass to deal with. But the easiest way to deal with the square root is get rid of it. And how do we get rid of the square root? We square it. All right. When we square it, we introduce new or potentially introduce new information. So it's worth noting down now any restrictions that are being placed on this stuff. If y over 9 is positive, and we've got y over 9 equals the square root of this is never negative. Even if I multiply the 9 over, 9 times this is still never negative. It can be 0. If x equals plus or minus 1, this is 0. So it can be 0, but it can't go negative. So this very thing places the restriction that y has to be greater than or equal to 0. Because the right side is non-negative. That should not be like that. I have a little glitch. The 49 is just underneath the x squared. It is not underneath the 1. So let me make the 1 bigger like that. There we go. So we will square it. Square, square. I have y squared over 9 squared equals 1 minus x squared over 49, which is basically 7 squared. And if I add the x squared to the other side, I have x squared over 7 squared plus y squared over 9 squared equals 1. This is an ellipse centered at the origin. And which axis has the major axis? X or Y? Y, yes. So the major axis is along Y. Which means that's where our foci will be. So, says graph it. So this is centered at the origin. And they made it kind of big. But I know y has to be greater than or equal to 0. So I really don't need the bottom half of this graph. That restriction is going to come in. But x goes left or right 7. And y goes up to 9. So I go 7 left or right from the center and up 9. For a full ellipse, we would go down 9 as well, but we do not have a full ellipse here. And this is gonna look almost circle-ish because 7 and 9 are both large numbers. And they're close numbers. They're not like 10 and 20. They look they're not that far apart in value. So it's almost as wide as it is tall. Correct. So our y greater than or equal to 0, restriction eliminates the bottom half. What is our domain and range here? Yep. And what about our range? Yep. Excellent. So that met the requirements for what the problem was asking. While we're at it, let's explore the foci and eccentricity. So if we want the foci, we're going to do c squared equals the absolute value of a squared minus b squared, 49 minus 81, which is 32. So c is the square root of 32, which is less than 6, but larger than 5. It's closer to 6. It's probably about, I'm going to go with maybe 5.6 or 7. Probably 5.65-ish, I'm betting. And that would put it right here, if they ask for it. And our eccentricity would be that c value, square root of 32, over the half the length along the major axis, which is 9. That's the max of A or B. The maximum is 9, between 7 and 9. Which is probably around 0.65, probably also. All right, any questions on that one? With that in mind, let's look at the next problem. And we will see how you guys do on your own at first. X equals negative square root of 1 minus y squared over 4. And we want graph, domain, and range. Yeah. Do we have a restriction? We're going to. Can X be positive? X can't be positive, can it? It can be 0 if Y is 4 or 2. If Y is 2, this gets down to 1 minus 1 is 0, and that would be that. But other than that, anything we do in here should be positive. If we if Y is too large, this becomes complex and we can't even graph it. So we do have a restriction. X can't be negative or positive. This one's a little sneaky. I like it. It's really sneaky. So how do we proceed from here? Yeah, we're going to square it. We don't like square roots. And if I add the y squared over 4 to the other side, I have x squared plus y squared over 4 equals 1.
Yeah. What happens to the negative outside the radical when it's squared?
So picture if I squared -2. Remember what squaring is.
Oh, okay.
Negative times a negative is a positive.
So it's just like.
Yes. So that's just a little example. Let's say the square root was 2. Any negative, so the same thing happens here. The negative, I have a negative times a negative, the negative goes positive. I'm glad you guys asked. There's questions on it, well, that needs to be cleared up right away. Okay, so it kind of looks like a circle because we've got x squared plus y squared equals 1, but the y squared is over 4, which tells me this is an ellipse because I don't have a 4 on bottom of x squared. It's centered at 0, centered at the origin. What is A and B here? B is 2. A is what? It's just 1. I can always write that as a fraction over 1, and so that's exactly it, it's 1. So, and we want to recognize x has to be less than 0, so we're not really going to have a right side of the graph here. B tells me my major axis is along Y. I'm going to have half of an ellipse again. So what is my domain in my range? Mhm. Yep. All right, where would my foci be? Let's find our foci. We need c squared. C squared is the absolute value of a squared minus b squared, which is 1 minus 4, which is 3. So c is the square root of plus or minus 3. Well, it's exactly equal to plus or minus 3. It's approximately plus or minus what, 1.7, I think is the square root of 3, 1 decimal place, which puts the foci close to the tubes. F and F. So that would, if I wanted to put them as coordinates, it would be 0 plus or minus square root of 3. And if I want to find the eccentricity, I want C over the max of A and B. The max of A and B is 2. And C is square root of 3. So E is approximately 1.7 over 2 is about 0.85. That's without getting out a calculator for any of that crap. I have no idea what the actual value is. That's a good question. For the last one, the other foci would be down here. So it's still technically there. I mean, but we didn't use it, so I didn't bother putting it. The other F would be down here somewhere. Foci go on the major axis. They both happen to be Y here, but the restriction or which half of the ellipse we had was different for each one. Any other questions? How about the folks online? You guys doing good?
All good. Yes.
All right. All right, one more question. I love that you brought questions. This makes my job easier. I don't have to make shit up. We have write an equation for the ellipse satisfying the following conditions. we have foci at 0, -5, and 0, +5. And the point (24,5) is on the ellipse. There is no way, 24, there's no way that's possible. You're sure you have the number written down right? Because (5) means the y value, and that puts the foci on the ellipse as well. There's no way that's right. Let's just put a different value there. Let's call it. Oh shit, this is gonna work. Let me scribble this on the side real quick and see what will work. Yeah. Calculator, there you go. Hey. That's not gonna look very good. Let's see. Let me pick a different P. I don't like the way that P is looking. That should work. Let's put the point 012 is on the ellipse. When you're looking at the homework on that one later on, I know this is from problem. Do ask my instructor, send it to me, because I'm kind of curious what the problem was. If it gave 24,5, there's a fucking problem. The foci are not on the ellipse, and that would, I guess that. No, I guess the 24,5 would work. Because that's not along the axis. Never mind. Let's try that. Let's go with 24,5. Let's see what happens with it. It is possible. Okay, so we've got two pieces of information, piece A and piece B. What does piece A give us? The piece A gives us C, right? What is C here? C is plus or minus 5. All right, good. We know it also tells us one other thing. The center is between them, and between those is 0, 0. So I have. The default equation we have going on right here is x squared over a squared. Plus y squared over b squared equals 1. And we know that c is the square root. We know a is bigger because we also know a is larger than b from that line because the foci are along x. So a is bigger than b. I don't need the absolute value anymore. I know I have that. Or c squared equals a squared minus b squared. Or I could say b squared plus c squared equals a squared. Which is what I'm going to do. I have two equations. I have this piece of information right here. I can plug in values for x and y here, but I still have a squared and b squared. I still have a's and b's. I don't know what they are here. I know what c is here, so I can get this. This is going to be b squared plus 25 equals a squared. So that's one equation I can work with. The other equation is 24 squared over a squared plus 5 squared over b squared equals 1. I have two equations and two unknowns. My unknowns are a and b. This is not the most delightful problem. But we got to go through and solve it. So what I'm going to do is, God, they made this ugly as hell. We're going to clear fractions by multiplying through by a squared times b squared. So I'm going to do that without canceling anything out because I think saying it out loud is a little confusing. But if I show you what the hell I'm talking about, then you might be okay. I literally multiplied everything by a squared b squared. Now, if I clean that up some, I have 24b squared plus, not 24, 24 squared plus 5 squared a squared equals a squared b squared. I'm going to write in a value for those because I don't like dealing with having those squares. This is 576 b squared plus 25 a squared equals a squared b squared.
I have a question.
Yeah.
You said the major axis is along the x because a is greater than b, right?
I said the major axis along x because the foci are along the. I said that all wrong. They're along the y-axis, aren't they?
Yeah.
So this is completely false. Let's change that around. So I could do b. Okay, this changes some of this. This changes this part. Let's fix that. You're right. B is greater than A. So if B is greater than A, I can still get C. I can dump the absolute value signs if I make it B squared minus A squared. So if I square this, I've got C squared equals B squared minus A squared. And if I add a squared to the other side, I have a squared plus c squared is 25 equals b squared. We'll use that equation. Good catch before I started digging into the weeds here. Okay. I'm gonna replace b squared in this equation here. We're gonna take this and we're just gonna, it's like plug and play. And it's gonna be ugly as hell. But we don't have a lot of options. B squared is a squared plus 25. God, this is a shitty problem. Is this more like the last ones? This is shitty. 576 times 25 is, if I do some distributing, I have 576 a squared plus 14,400. And then I've got plus 25 a squared equals a to the fourth power plus 25 a squared. Well, that's kind of convenient. I am not going to combine, I was going to combine these two, but I've got 25 a squared on both sides. I'm gonna clear those, and those are gonna wipe out. And I'm gonna subtract everything so it's on the right. If I subtract the 576 a squared and the 14,400 over to the right, I have a to the fourth minus 576 a squared minus 14,400. This will factor into something, I don't know what. So rather than trying to, if I tried to factor it, this would be a squared and a squared something. Does that make sense? Instead of doing that, I'm gonna use the quadratic formula instead of trying to factor 14,400. So a squared equals negative b, which is 576. Plus or minus b squared, which is 576 squared, minus 4 times 14,400. All over 2. Answer 4. Okay, 576 squared. Answer. Square root of answer. Okay, I'm getting a squared equals 576 plus or minus 523.6. I can't believe this is the problem. Over 2. So let's see what the 2 end up being. Plus, oops. If I do the plus 1, I've got 549.81. And if I do the minus 1, 2. This one is like 26.19. So if I take the square roots of these, one of these is going to be viable and make sense, and the other one is not, based on the foci. Square root of that. This one's about 5.1. And what is square root of? Okay. Did anyone else do this and get the same A's? Before I go further, I want to make sure that we're getting the same shit. Square root of 576 squared. Oops. 576 squared minus 14,400. Oh shit. Oh, times 4. 522. I'm getting that still. Okay. Those still look like valid values. So let's look at what the b squareds would be for each of those. If A is approximately 23.44 and the A squared is the 549.81, we have 549.81 plus, that's my, I'm doing the A squared plus 25. That's what I'm plugging into right now. Equals B squared. So square root of 549.81 plus 20. So B squared of B equals, right, once I take the, when I add those up and I take the square root, I got 23.975. If I do A squared equals 26.19, I got 26.19 plus 25 equals B squared. 15, sorry. And so here B is approximately 7.15. Here A was 5.1-ish. That was supposed to be 0.19. I don't think it's going to change B much. Nope, still 7.15. Excellent. Okay. Let's look at both. If I've got 5.1 and 7.15. I've got an ellipse like this. X can't be 24. There's no way I can get an X of 24 like this. So that's not it. Neither of them has it getting an X of 24. I fucked up somewhere. X caps out at 23.44 on that one. So what did I do wrong? There's something wrong somewhere in here. I had X squared over A squared plus Y squared over B squared. I plugged in the values, which is that, and I multiplied through by B squared and A squared. Is that not 576 times 25? 576 times 25 is 14,400. Yeah, to end up, but something is wrong. Because to end up with a negative number or negative right here, one of these has to be negative and one of these has to be positive. And I don't have one of them is negative and one of them is positive, which means I screwed up somewhere in this. There's an error in there. What is the error in there? So X is normally negative B plus or minus the square root of B squared minus 4AC all over 2A. But X here is A squared. That sucks because they're both, I'm using A for two different purposes. Negative B is negative. Oh! C is negative. This should have been 576 plus or minus 576 squared plus 4 times 14,400. That's where I fucked up. I had minus, but C is negative. So that should end up being, cancels out the minus there. That's what I did wrong. All right, let's figure out what the new values are. I know that we're just like totally past our timer here. But now I want to know, and I blame this on this shitty problem. Square root of 576 squared plus 4 times 14,400 equals. That's an easy number. That's 624. There we go. Nice numbers. So it's 288 plus or minus 312. So A squared equals 600. Is that one of them? Or A squared equals negative 24. And A squared can't be a negative number, so A squared's got to be 600. That's awesome. So A is square root of 600. Let's make sure that I have that right. 576 plus 624. Yeah, answer divided by 2. And square root answer. A is approximately 24.49. But A squared is 600, so that's going to be what's right there. B squared was A squared plus 25, right? 600 plus 25 is 625. That's the equation. There we go. Bucket found it before the clock ran out. That was a bitch. So I'm gonna cross out this shit right here. And this is wrong. And this is wrong. So when I scan the notes, we'll see it. And I don't need that because I was with the wrong shit. There we go. Not pleasant. God, I should make it. Final exam have some shit like that, right? Make everyone hate Mr. Jones.